Hello, I'm Michael O'Connell, and in this video tonight, I'm going to show you how to get a sample of water to be at its triple point. This is actually something that is pretty easy to do and can even be done at home, and I'm going to use a very simple example to demonstrate this. So I have my water bottle here, and this water bottle is about 40% full of liquid water. And previously, when I was drinking out of it, I had this open, the lid open, and what that means is that above this liquid water we have a mixture of gas, right? We have air and we do have some water vapor. So when I close and seal this, I do have my closed system. The problem for us is that this phase diagram I have on the screen does not accurately represent what is happening inside of this water bottle. Because, in fact, there's not just water in this water bottle, there's also air. So in order for this phase diagram to be used and accurately represent what's going on here, we need just water. We need this to be pure. And there is actually a very, very easy way we can do that. Now, we might want to use a more sturdy vessel than this plastic water bottle, but what we could do is actually boil this liquid water such that more water vapor is formed. So we would start to see the bubbles, right? The water starts evaporating. And what that water vapor is going to do as it forms eventually is it's going to push and push and push all the air out, okay? And this, in fact, will not be super difficult anyway because air is actually much less dense than water as a fluid. So at a certain point, as this water is boiling, as we've given it enough time, there's not going to be any more air. And that's when I grab the lid here and I seal the water bottle, okay? So that way, now we have just pure water in my water bottle. And now what this phase diagram shows before you here does apply to our situation. Now, what's important to realize is that with enough liquid water and with the water vapor inside, there is an equilibrium between the water vapor and the liquid water. And what this means is that when we're at the boiling point, we know that the normal boiling point of a liquid substance is when the vapor pressure, so the gas above that liquid, the vapor pressure above that liquid, is equal to the atmospheric pressure, so the pressure from the air around us. When those are equal, that is the point at which the water is said to be at its boiling point, correct? And that's obviously at a certain temperature, which we know is 100 degrees Celsius. So on our phase diagram here, we would have 1 atmosphere over here somewhere, and then let's say 100 degrees Celsius somewhere here. And like I said before, the important thing to realize is that with the amount of liquid water we have in here, there is going to be this equilibrium that is established within this closed system. And what that means for us is that our boiling point here is on this curve. If you can see my arrow right there, it's actually called the vaporization curve. So that's where we are. We're like right here somewhere. Okay, we're at 1 atmosphere, 100 degrees Celsius. So now we're tasked with getting this to be at its triple point, right? Ice, water vapor, and liquid water, of course. And the way we can do that is actually just sticking this into a freezer. And you might think, well, how the heck would that work? Because it's all just going to freeze. And that's actually not the case. Because what we have to remember here is that this pressure is the vapor pressure on the y-axis here. That is the vapor pressure, the water vapor above this liquid water within my vessel here. Okay? So this temperature, when we decrease it, when we decrease the temperature of the liquid water, the vapor pressure will also decrease. And because there's been that equilibrium established, that's not going to change just because we throw it in the freezer. What will change is the temperature, and likewise the vapor pressure. So at a certain point in time, we're going to move all the way down this vaporization curve right down to the triple point. And what we're going to have left is some liquid water, water vapor, and actually some ice in there, because we are at the triple point of water where all three phases of water are going to be present at once. And obviously, like I said, this is not difficult to do. You could literally do this in your kitchen. So I hope my explanation was sufficient, and I hope this video was edifying for you. And thank you so much for watching.